everyone. It's nice to meet you. I'm subbing in for Mark today, and I'm super excited to chat with one of our other PMs on the team, Abhinav Tripathi, on Materialized Views. So, without further ado, let's get started. Abhinav, do you want to introduce yourself?
Hey, hi Tara. Thanks for having me here. Hey everyone, I'm Abhinav. This is my second session in Cosmos Azure Cosmos DB Live TV. So today I'll be talking about Materialized Views. I'm a PM in the team. It's been almost 2 years uh, for me in Cosmos DB. So yeah,
Awesome. Yeah, looking forward to it. Um, cool. I think we can get started. We have a pretty good audience here, so as always, like feel free to chime in and let us know if you have any questions about the topic.
yeah. So Tara, today I'll be talking about materialized views for our audiences. So in Cosmos DB, it becomes very important to model the data properly, and a lot of times, depending on the choice of partition key, users end up performing a lot of cross-partition queries. So materialized views basically help users to create secondary data views with a choice of a different partition key. They can choose a subset of data and keep it aside in a different view. So materialized views give that capability, and it helps users in avoiding a lot of cross partition queries, and cross partition queries are very expensive. So by avoiding cross partition queries, they can basically reduce their bills as well. So this is a feature that lets them optimize their costs.
Nice. Yeah, that sounds like it'll be super useful for a lot of customers. So I'm sure they're super excited to hear about it as well.
Yeah, so you know uh, I have put together an example use case for a better explanation, so that users get a better feel of what we are talking about. So let's consider a hypothetical situation where a partner customer is building a telemedicine platform. Here the patient consults a doctor, and their information is being stored in a single documentation. So every time a patient visits a doctor, there is a consultation created, and that is stored in a single document in Cosmos DB, where you have consultation ID as the partition key. And this is very important to note here, that consultation ID is the partition key in this example. And then if you notice here, there is consultation date, then other details, and then who is the doctor related to that consultation, the details related to the doctor and the patient. So this is a example document that is being saved for this application. uh, we can see like how if we move further, we see how you know this information is used in the application. So if we go to the uh, next slide here. Yeah. So if we go to look at this one, so once the data is stored in Cosmos DB, how is it utilized? How is it used in the application? So let's say there are two views where this data is being used. One is a doctor view and the other one is a patient view. And when the doctor is searching for something, they can specify either the patient ID or the consultation ID. Similarly, if the patient is searching for something, they can specify the doctor ID or the consultation ID. So what happens, as long as both of them are specifying just the consultation ID, it is all fine. But the moment they choose something else like patient ID or the doctor ID, it might become a cross partition query, because if they have a lot of data and they have multiple partitions, uh, it might become a cross partition query if they do not specify the partition key as the part of the and the ID as the part of their query. So here, if you look at this interface particularly, as long as they specify consultation ID as the part of their query, it is the ID and the partition key, so it is all fine. But if they choose to use patient ID or the doctor ID, that's when the things might become really expensive for them if it results in a cross partition query.
Makes
So
sense.
yeah, so at that point, we need to understand what makes cross-partition queries so bad. Why should
Mhm.
we avoid those, right? So uh, if you look at how data is stored in Cosmos DB, let's say in this example, we have a 50 GB data in a collection, and the workload is distributed such that there are 10% writes and 90% reads. So if we look at the reads, they can be two types of reads. It could either be a read with a partition key or without a partition key. When we perform a read with partition key, it is inexpensive and fast. Whereas if we choose to perform a read operation without a partition key, it might be expensive and slow. And to understand why it will be expensive and slow, uh, we need to understand how data is distributed among the physical partitions and the logical partitions in Cosmos DB. So let's assume that this black box is a physical partition. If we are looking at the data, this black box is a physical partition, and this orange oval is a basically a logical partition representation. So what happens in Cosmos DB when we have a record? If we go back here, if we specify consultation ID as a partition key, so for each unique value of this consultation ID, there is a logical partition. So depending on the choice of partition key, uh, all the values with the same partition key value will be mapped to the same logical partition. So if we have a partition key value as pk1, it will be mapped to this logical partition, which will reside inside a physical partition.
Makes
Then
sense.
similarly, as the data grows, Tara, this there will be multiple logical partitions, right? There will be multiple values for the partition keys, and similarly, this data gets distributed among these logical partitions. For the data that has partition key value as pk2, it is mapped to this logical partition, and all the data that has partition key value as pk3, it is mapped to this logical partition. So now, right now, we have just one physical partition which has three logical partitions inside it in this example. But as the data grows or the throughput requirement grows, these physical partitions get split into multiple physical partitions. There are more physical partitions, those are required, and the data gets redistributed among those physical partitions. So as the data grows or the throughput allocation grows, there will be partition splits, and this data will reside among multiple physical partitions. And as the workload requirement grows, this keeps on growing and growing. So what happens now? Consider these two reads example. If I specify the partition key, uh, Cosmos DB, Azure Cosmos DB will know specifically which physical partition it needs to go and look for that logical partition and find that item that a customer has queried for. But if we don't specify the partition key, we have to look into all these partitions here, 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 and all over. So if we have a lot of physical partitions and we do not specify the partition key, then it becomes a expensive affair. So this is how the cross partition queries become very expensive, and we must avoid that.
Makes sense. Okay. Yeah. So I guess um, one question here is, um, I guess like depending on if a user uses this feature, is there an extra like cost involved?
Yeah, Tara, I'll come to that. There are costs involved at several levels. I'll come to that.
Okay.
So before that, let's address our problem statement. So we talked about the problem statement where we were storing consultation ID as the partition key, but the user might need to use, if we go back to our example, the user might need to search with the patient ID or the doctor ID. So uh, there are several use cases uh, such like this one where the customers have a different partition key in their source container, but in the application they need to use some other IDs. Classic example will be somewhere for telecom operators where they have, account IDs and the mobile numbers, or email IDs or the mobile numbers. So there could be several different fields on which the queries happen, but they can have just one partition key. So in such cases, what helps is, it could help if they could divide this data among several containers in different collections. They could keep this data, and then, depending on the application requirement, these in this collection they could specify a different partition key. So for this particular example, if you saw, there were a lot of fields in the source collection, more than 600. But let's say for this particular screen, what we require is just the patient name and the date, consultation date. For this screen, we just require the doctor name and the consultation date. So it makes sense if we have data structured in a way where we are not scanning through huge amounts of data, if we are uh, able to specify the partition key. So it makes sense if we could divide this collection into three different collections here, uh, where one had consultation ID as the partition key, and the other one had doctor ID, and the other one had patient ID, and the other required fields, so that when the customer specifies, the application user specifies patient ID as one of the search fields, then we could just look at this collection, and we could specify the partition key, and we could avoid the expensive cross partition queries.
Yeah,
uh, yeah. Similarly, for doctor IDs, it could go and look up into this collection. So how do we do that in Cosmos DB? That this is where materialized view features come in. Developers could try to do this themselves, like they write to a source collection, and then they write their own custom logic to propagate, pick up selective information and propagate to three different collections. But it comes with a lot of overhead. They have to make sure that data is properly written to the destination collections, and if they are hosting an application that takes care of syncing data, then they have to manage that hosting also. They could use full change feed feature for that, but there is a lot of code maintenance that is required on that front. And on top of that, they also need to maintain monitoring requirements. Like if they pick up the destination collection at any point of time, can they be sure that uh, the data is in sync with the source collection? So all those monitoring capabilities also need to be built. So it doesn't make sense uh, for a developer to perform those many tasks just to keep the data in sync. So we came up with this feature where all of this happens automatically, and it takes away a lot of development pain points. So how do we do it? uh, the application writes to the source container. So here we have the source container. If you recall from the starting of this session, this was how the source collection looks like. It had more than 600 fields, and now we have something like this. Treat it as a black box. We have materialized views builder, which process the change feed, and they write the data to the destination containers. So I will come to your question, Tara. You asked, is there any cost involved in this? So materialized view builders are basically the compute instance, uh, and I will show you like how to use them. But this picture basically summarizes how the materialized views in Cosmos DB work. So the application writes to the source container, and then using the materialized view builder and the change feed, this data is read from the source container and then written to the destination containers.
got it. Makes sense.
So, yeah.
Uh,
So talking about the cost, Tara,
yeah,
uh, you see that data flows from source container to the destination container, and there is a compute instance in between, right? So there is some RUs which are consumed at the source level to read the data from the source container, and there are some RUs consumed at the destination container level to write this data to the destination containers. And then there is also a compute cost which is charged at the hourly basis depending on the choice of the SKU. So yeah, this is how the customer incurs cost, and there is a cap of basically when this data, we can come back to that later. There is a cap of how much RUs can be utilized.
makes sense.
Yeah.
Okay. We actually have one question from Rob in our chat, and he asks, can you change the partition key on a container and have the data redistribute in place?
No, so that is not the point of the materialized views. You cannot do that with materialized view feature in place. Materialized views basically let you create secondary data views. So it will create a new container. It will not make those changes in place. So there are other features for that. So materialized views does not do that.
Gotcha. And then, so you mentioned that the MV builder reads the data from the source container. Does this have any impact on the read and write performance of the source container?
Okay, yeah, that's a good question, and I almost talked about it earlier. So, as I mentioned, there will be RU consumption here and here. So, what happens? We have a cap imposed on how much of the RUs can be consumed
Right.
for reading the data. So, let's say if I allocate 1,000 RU per second throughput on the source container, only 100 RUs per second will be used for reading this data from source container, and then at the destination container level, up to 50% of the allocated throughput can be used to write this data. And uh, if we were to ask like how why 10% cap here and 50% there, because here we are reading the data. Reads are much more cheaper than the writes, so here is a cap of 10%. It will serve our purpose, and on this side we have a cap of 50%. So
Got it.
yeah.
Okay, that makes sense. Let's see if anyone has any questions. I think we have one new question, and this user is saying, what is the difference between a normal collection and a materialized view collection? So I think,
All right.
yeah,
Yeah. So materialized view collections are similar to the normal collections in almost all the sense, except for the fact that uh, the user cannot directly write data to the materialized view collection. The data to the materialized view collection can only be written by the materialized view builder instances, and that makes sense because we make sure that this data is always in sync with the source collection, so we do not allow the users to make changes to the data in the materialized view collection. So whatever changes happen in the source collection, they will be automatically propagated to the materialized view containers. Except for that, except for this write restrictions, the materialized view collections are almost the same as the source collection.
okay, that makes sense. Would it be possible for could you just create one materialized view which would sync data from multiple collections?
Oh, yeah, that is not possible. So that is not possible, and consciously we have not, implemented that feature because uh, that is kind of an anti-pattern. So it is akin to joins basically. So right now we support single source collection, and on a source collection we can create multiple materialized view collections. Yeah.
Makes sense. And then I think we
So
have one more question from a customer, and they're asking, we talked about the differences between the normal collection and materialized view collection, but when it comes to setting throughput and RUs, is that the same? Like, what are the differences for a normal collection and when creating the materialized view collection as well?
okay, okay. So, Tara, let me take that question a bit later. So, let me show you how we actually create the materialized views. So,
Sure.
a lot of those questions will all be covered in the process, right?
Cool.
So, yeah. Uh, so, let's quickly see what is the process like. How can we get started with using this feature? So, I have taken, created a source container. So, this is a source container here, and it has ID, mobile, and email fields. And in this example, what we will try to do, uh, we will try to change the partition key here. So if you see, ID is the partition key here, and we will try to replicate this data in a new materialized view collection where we'll make mobile or email as the partition key. So let's see how we can do that end to end. So first step is, we have the source collection, and then because this feature is still in preview, so we have to enable this. So at the account level, we go to the feature setting, and then we click on this enable option. It takes some time to enable this feature on the account. So this feature is enabled at the account level, and once this is enabled, the user starts seeing this materialized views builder option. Before enabling this feature, this will not be visible. So after enabling this feature, this becomes activated here in the menu blades. And then the user has to uh, create a materialized view builder instance. If we go back to this slide, this is the compute instance which takes care of reading the changes in the source and then propagating it to the destination collection, right? So we do have to provision this uh, compute instance. And where does it happen? It happens in the Materialized View Builder option. So currently it is in deprovision state. I click on this toggle switch, and it becomes provision, and then I get an option to choose an SKU. So SKU we can choose depending on like how many cores we require, how much memory we require, and this becomes important in monitoring as well. Later on, we'll see like how this plays an important role. So uh, it is important to understand that we have to, allocate a proper SKU size here, number of vcores that we choose, depending on how many writes are happening on the source container, because this Materialized View Builder instance will process those writes and take it to the destination container. So for this example, I choose the lowest one, cosmos.d2s, which has 2 vcores, and I allocate one instance of this one and click on save. So it will take some time and it will provision a Materialized View Builder instance.
So is
After
there
that,
any sorry,
yeah,
just one question. So is there a
yeah,
limit on like the number of materialized views that we can create on a single source?
yeah, Tara. So right now we are limiting it to 5 collections. And if you might ask like why that limit is there. So uh, remember, like, there are RUs that are consumed here when we read data from the source collection. So we don't want uh, these RUs to be distributed among a lot of materialized view containers, so that this happens almost instantly. Otherwise, what will happen if we have a lot of Materialized View containers? Then the user will have to increase throughput allocation on the source container. So this 5 container limit is a soft limit. We can increase that. But right now we have put a restriction of 5 Materialized View collection on a single source collection.
Got it. Makes sense.
Yeah. So I was talking about the builder instance. So the first step is basically to create the Materialized View Builder instance. And then you must be wondering like how does the builder know what to populate in a particular destination collection, right? So for that, we have a Materialized View definition JSON file that we will save. It is similar to the parameters that we specify for container creation if we are using Azure CLI. And creation of materialized views is currently supported through Azure CLI only. So we'll see that part. So this is how a typical MV definition.json file looks like. We specify the location and all those parameters. And here we need to notice this part ID. So this is the name of the materialized view container that we are creating now. So on line 6, if we see the ID, this is how we specify the name of the materialized view. And then on line 8, if you see, we have specified the partition key path and changed it to mobile. Earlier, we had ID as the partition key path, but now we are making mobile as the partition key. And if you look at line 11 to 14, this is the new section that is introduced, which is different from the normal collection definition. This is the materialized view definition. Here we specify the collection ID. Basically, here I have put a screenshot with source collection name. This is not correct. It should be source collection ID. And we specify the source collection name here. And then we specify the definition. Basically, definition is a query that picks up information from the source collection and then dumps it into uh, the destination collection. So in this example, since we were going to replicate all the data from the source to the destination container, we have done a select star from root. uh, Currently we are supporting in query grammar, we are supporting select star or select field 1 comma field 2 comma field 3, basically a subset of fields from root. We are not supporting any conditional statements as of now uh, during the preview, but support for those things is planned in future. And you talked about the throughput. So this is how we set the throughput on the destination container. We can specify it here, or even after we have created the materialized view container, we can tweak this setting.
Got it. Makes sense.
Yeah. So once we have this definition in place, we have already put the materialized view builder instance up and running. Now we have the materialized view definition in place. The next step is basically to make a REST API call using Azure CLI, and then uh, the materialized view collection gets created. So here is an example. So you have to, obviously log in using AZ login, and then there is a REST API. The method is put, and in body we supply this mv definition.json file that we just created. And in the URL, it's a typical, management .azure.com, where we specify the subscription under which your Cosmos DB account is allocated, the resource group, and then the database account in which your source container is present, and then the database under which your source container is present, and then the name of the uh, new materialized view destination container that you are going to create. And here, if you notice, this API version is 2022 11 15 preview, because this feature is in preview. We have to use a preview API version. So this is how a typical REST API call looks like for creating a materialized view. We leverage the MV definition that we just specified in mv definition.json file, and then make this REST API call. Once we do this, we'll get the status enqueued message, and then we can head over to the portal and see if the materialized view is created or not.
Got it.
So here, if yeah, so so if we go here and refresh our portal data explorer list, right now we see just mv source, and if we click on refresh, we see that mv demo items are also there, and this is the same name that we specified in our mv definition.json file and during the REST API call. And now this is what I was talking about. Now we have changed the partition key. Earlier it was ID, and in this collection now it is mobile. So this is how you can, change the definition. You can specify which fields to populate, and if you look, we use select star, so all those fields have come to this mv items. If we had done selectively, like select mobile from root, so it would have populated only mobile field.
Got it. Makes sense. We have one question, and this is: does Materialized View support indexes? And a follow-up question to that is: in the case of select star from root, do we need to assign equal numbers of RUs to Materialized View as the source?
Yeah, it does support indexing. As I said, it's similar to your normal collection in most of the ways, except for the fact that you cannot write directly to your materialized views containers. And the second question, Tara, the second part is like, uh, is the question asking if the number of RUs or the throughput allocation on the source container should be same as the destination container? Is that the question?
Yes.
No, no. So that doesn't have to be the case. And for that, let's go back to this one, right? So let's say again, in example, if we had taken 1000 RUs per second as a throughput on the source collection, now those 1000 RUs will be utilized for read and writes. Okay. So let's say in my normal use case, 20% writes were happening. Okay. So out of those 1000 RUs, 200 RUs will be required for writes. All right. And only those writes need to be propagated to the materialized view containers. Now what happens, although you had 1000 RUs on your uh, source container, but those were for both reads and writes. But here you have to take those writes and write some values on the your destination container. And this destination container, all three of them might have distributed throughput requirement now. Sometimes it might be in use, sometimes it might be used in use, and then uh, in different times it might be in use. So you need not have, the same throughput as the source on this one, depending on your application requirement. If most of the users are using the consultation ID, so you can tweak and increase the throughput on this container as opposed to the other two. So it's all configurable and it doesn't have to be the same one.
Got it. Makes sense. That's nice.
Yeah. Are there any other questions related to that part?
Nothing yet, but we'll keep you posted if
Yeah.
anything comes up. Yeah.
Yeah. So while talking about the benefits of materialized views, Tara, I pointed out another thing about monitoring capabilities. So that part also I want to cover. How do you know that your materialized views are working properly? Are they in sync with the source container or not? So that becomes very important. If somebody was to, implement a custom solution where they read from the source collection and dump data into the destination container, they have to make sure that, everything is seamless, everything is up and running, and then the data is syncing properly. But that again becomes, a tedious job for somebody to put out a team specifically to do that. So in Azure Cosmos DB Materialized Views, we have those features inbuilt. We can monitor if our materialized views are getting populated properly, if they are lagging behind or not, and we can debug basically whether we want to increase the RUs or we want to, change the MV builder compute setup. So that takes me to the last part where we talk about uh, monitoring of the materialized views. So if we go to the metrics section and we choose this metric, materialized view catch up gap, so it shows you what is the catch up gap in minutes. So basically it tells you how much far behind is your materialized view as opposed to the source container. So right now in this example, because I never saw any gaps, and it was always instant, so in this example you see the gap is at 0. But there might be instances, depending on if you had very few RUs allocated on your source container, or there are too many writes on your source containers and the MV builder instance is under provision, so you might see higher catch up gaps here. So, and in that situation, what to do? What do we do? If the gap is acceptable, that is fine. But if the gap is not acceptable, let's talk about how we can debug that, right? So we then need to look at the CPU utilization of our materialized view builder instance. So builder instance is basically a compute. There is CPU and memory utilization. So if either of them or both of them is very high, it might lead to slower population of materialized view containers. So it helps us to look at these metrics. If the catch up gap is high, then we can look at the average CPU utilization here. And in this case, if you see that average CPU utilization is very low, but there might be cases where it might go as high as more than 95%. And then at that point of time, we need to worry about like how if there is any further increase in the workload on the source container, do we need to allocate a higher SKU. So this is one metric where we can look at average materialized view builder average CPU usage. Or we can also look at the materialized view builder average memory usages. So each compute instance, the materialized view builder instance had we saw a certain number of vcores and a certain amount of memory. So out of that, how much is being used? So in this example, only 2.5 gigs of memory is being used. I think the memory allocated was 8 gigs on this one. So we are all good in terms of memory as well, so we are not over utilizing or anything. And anyways, we saw in our example that the materialized view catch up gap was 0 minutes, so it was in sync. But yeah, it helps us in looking at these numbers. And then we also have maximum CPU usages metrics. So what happens, how to decode this process? If the catch up gap is high, and one of these metrics is also going to almost 100%, then it might help the user by increasing materialized view builder uh, specification to a higher SKU. But if this is in check, and then still the user is seeing high catch up gap, then the user might consider going back and look at how much is the RU utilization on the source container and the the destination container. And if one of them is going constantly 100%, then they might benefit by increasing that throughput allocation on the source or the destination container.
Right, that
Yeah.
makes sense. Cool. I was wondering, since this is a preview feature, do we have any, or I guess like, what is the overall customer sentiment of this feature? Do we have any like success stories or like any customers we can pinpoint that have actually really liked using this feature and what their use cases are?
So, Tara, I can definitely not take names here, but yeah, there is a lot of excitement around Materialized View features. We are seeing quick adoption on this feature. So this has been in demand for long. So it was already there for our Cassandra API, and it wasn't present for NoSQL API, but there was a fairly huge demand for NoSQL API support as well. So that's why we took it up, and we are seeing adoption on this one. We
Nice.
we are seeing like continuous increase in the number of collections, materialized views collections, and the request counts on those ones. So yeah, this feature is already in demand.
Cool. Awesome. Yeah, it's good to know that it's already in demand and it's just a preview feature. So, what would you say to users that are a bit wary of using this feature because it's in preview?
Yeah, there are a certain set of limitations right now, but all of them are work in progress. We are trying to address them. Like if you look at RBAC support, so currently that is not there. CMK support is not there. If somebody is using continuous backup better, then they cannot use materialized view features. There is a long list of limitations right now in preview. uh, uh, all those have been documented, so the customers, either while enabling this feature, they will get to know if they can use that feature on a particular account. So they'll get to know if they are not able to use, they'll get to know why they are not able to use, they'll get that message. But these limitations have been documented in our public docs, and uh, there's a list that the customers can go through. but all of them are work in progress. We are trying to address all those limitations.
Makes
So
sense.
the
Yeah.
customers need to be uh, aware of those limitations before using it.
Yeah, it makes sense. So you mentioned that there will be like some explanation if the user is not eligible and what criteria they don't meet. Is that through the portal where they can see that, or
Yeah. So when they go and enable the feature here, so if this feature is not supported and they click on enable, then it will tell you that okay, this account has this feature active already, so materialized views are not supported. So
got
they
it?
can see it in the portal itself.
Makes sense. Cool. All right,
Yeah.
that's all the questions I had. Was there anything else you wanted to add before we think we're
Uh,
still waiting on some questions from customers. So if anyone has a question, go ahead and put it in. But was there anything else you wanted to conclude on?
yeah. So this is a feature we are working closely with our customers. We are also seeking more and more feedback and what could improve this feature. So we are very open to the suggestions through our public forums, through our dev blogs. So the message to the viewers and the customers is like, please go ahead and try it out. If you find something that can benefit, just like reach out to us, and we take up the user feedback very seriously, and we are constantly looking for improvements. So we'd be happy to address those features. Yeah.
Yeah, it sounds good. I'm not seeing any follow-up questions from anyone, so we can go ahead and wrap up here. Thank you so much for joining us. For all the viewers out there, Abhinav is joining from India, so it's definitely very late there. And I think, oh, I see one more question from a customer. It says, as per your screenshot, consultation ID or patient ID search, where will the query be sent? Where the query will be sent, materialized view and source collection.
No,
Um,
so yeah, let me get to the presentation. uh, yeah, so the question is where the query will be sent, right? So
yes.
materialized view collection, if you see, it is a new collection altogether now. So if you look at this one, there was a source collection, and now there is a materialized view collection. So it depends on now the it is upon the application developer to choose where to send the query, whether they want to do it query it from the source collection or the uh, the materialized view collection. They are free to do that, but the fact that they are using the materialized view feature,
Yeah.
it indicates that they want a different partition key. So depending on whether somebody has in this example specified the patient ID, so they could send the query to this collection, and if somebody had specified doctor ID, they could send the query to this collection.
Got it. That makes sense. Awesome. And then following up on, you previously said like users can reach out to you with feedback if they have regarding the feature. Um, how exactly should users do that? Is there a Twitter at that they can tweet to, or any other forum where users can drop in that feedback?
uh, they Let me share an email ID in the comments, Tara. So I'll put it up there. So we are collecting feedback, but they can definitely reach out. They can comment on our dev blogs. I have put up a blog on getting started with Materialized Views, so they can put out comments there, and we constantly monitor those as well.
Cool. Sounds good. Um,
And yeah, we also monitor Stack Overflow, so users are uh, encouraged to ask their questions in public forums as well.
Yeah, sounds good. I think for a lot of my features, I've started using Reddit now to look at what users are saying about things. So if you post something online, we're probably going to find it, which is really useful to us. So thank you guys all for tuning in. Thank you, Abhinav, for doing this all the way from India. Go ahead and get some sleep now. But yeah, it was great having you on the show. And glad to have you back as well.
Same here, Tara. It was a pleasure talking to you today. And yeah, I think it was your first Cosmos DB
Yeah,
live TV session. All
yeah,
right.
first time screening. So yeah. Uh,
Yeah.
just since we're wrapping up the show, just wanted to promote our Azure Cosmos DB user group. And then feel free to check out any past episodes and catch us next week for a new episode as well. Thank you guys.
Thank you. Thanks, everyone.